The main idea of this circuit was to show how you can drive a relay, in this case a 12-volt relay, and then out of a op-amp. I have to say I struggled a little bit. A few weeks ago I couldn't get it working. But anyway, when you go to the World Wide Web, you will often see many circuits where op-amps here like this are driving a relay circuit. Say, for me the key was that I had to use a PNP transistor here to make that op-amp switch. And with op-amps there are many possibilities, especially when you want to drive, say, a certain circuit via light or sound or temperature. And when you have followed my channel, I have by purpose not used an op-amp to make a temperature switch, and the reason was that the hysteresis problem. Anyway, I want to tell more about that when it is possible during this video. Here the top view, you can use a 741 or a TL071. The 741 is the mother of all op-amps. The pin connections are the same. The TL071 has the good property that it has a field effect transistor input, so its input impedance is very high. And as far as I know, correct me if I'm wrong, the 741 does not have a field effect transistor input. To say the two most important electrodes, pin 2 and pin 3. Pin 2 is often referred as the Vref, so the reference voltage, and here the changing voltage. But when you do experiments with such an op-amp, you can surely see that it could be reversed, so that this is the reference voltage and this is the switch voltage. That's the reason why I made this circuit, demo circuit, though I have tried to use it in the temperature bus circuit that I developed and published on YouTube. Here are two potentiometers. Here is the op-amp. It is a TL071. It's here. And well, the key issue was, of course, to get that relay working when here at the output of the op-amp the voltage changes. Say on a certain moment when the say the measuring voltage meets the reference voltage, suddenly the op-amp switches at its output and gives out a high voltage here at pin 6, and that refers both to the 741 and the TL071, and that voltage must switch a relay. And this is a good idea. It surely works, and I will demonstrate it. You have to use here a PNP transistor and here an NPN medium power transistor. And here are the pin connections and the amplification factors for the BD13970 up to 150, and for the BC557 between 200 and 300. But of course you can also use other transistors, silicon transistors by the way, as long as they have the same properties, especially the amplification factor. So when this op-amp switches on a certain moment, it drives the Darlington drives the relay, and the relay switches on or off you can use the contacts in such a relay. Here you see it. They have in this case 6 pin connections. You can use the on switch when it is activated or the off switch when it is activated. It's all what you want and need for a certain electronic application. The diode prevents, say, voltage peaks that can damage the transistor. Not always necessary. I name it now the 1N4005. You can use any silicon diode that can handle approximately 500 volts or 1000 volts. The resistance of this 12 volt relay is 270 DC ohms. So, the complete circuit again. In fact, it's very simple. By the way, when you want to do experiments, you can replace this resistor of 1K, 1000 ohms, by this circuit. This is 470K and this is an electrolytic capacitor. Sometimes you can get other switch results due to the properties of the electrolytic. And of course also the properties of this 470K potentiometer that you can of course set to different values. That means that the Darlington, the relay switch, is switched on in another way. The crux, most important thing of this circuit are these 2 potentiometers. Well, of course you can think, well, what does this have to do with reality? It has a lot to do with reality in electronics, because when you set here a certain voltage to pin 2 of the op-amp and vary the voltage on pin 3, the op-amp starts to switch. That means that for this resistor you can also use, say, or even parallel the wiper to ground with a light sensitive resistor. When the light meets the resistor, it will surely have an effect here on the voltage that is set to pin 3. You can also use that here, by the way. And then the op-amp can or will switch. I can only encourage to do some experiments. Say, try to understand the logic of this circuit, a fixed voltage, and when the voltage of the sensor meets the reference voltage, it switches. And here is a demonstration of that. I've made 2 voltage here meters in the circuit. One is connected to this point here, this point, and the other one is connected here. So when you turn the potentiometers, of course the voltage will change. Let me do that and see what's happening. So I now turn the potentiometer here, that's this potentiometer here, 4K7. They move around 6.2 volts. You can set that with the help of this potentiometer. This is, say, the reference voltage. It ranges for a certain part the way how the circuit works. So now I'm going to change the voltage to one of the pins of the op-amp. You can see that the relay switches. Say, that's the key thing of this circuit. I'm turning that potentiometer now again to change the voltage on pin 3. And here you see how critical that is. there's not a big difference between, say here, the voltage on pin 3 and the voltage, say the reference voltage. So, hope it's visible. That means you can use this circuit as a switch for temperature, for light, for say conducting fluids. Well, there are a lot of possibilities to use this comparator circuit. It is a comparator or comparator circuit. And important to tell, I cannot omit that, is there's always the question of the hysteresis. Well, hysteresis means that there is a certain point voltage where the output switches, but there is say a lowest voltage where the circuit has to switch on, and a highest voltage where the circuit has to switch off, or reversed. Can also be reversed, and that depends on how you say use these two potentiometers. And the advice is, of course, do this experiment to get some insight about how this works. But about the hysteresis, you can change, say, the lowest voltage where the circuit starts to work again with the help of a hysteresis resistor. That's here. It can be between 1K, 1000 ohms, and 1 mega ohm. And normally it goes from the pin 6 to the pin 3. So when you use here a potentiometer in the order of 100K or 470K, 470,000 ohms, you can set the hysteresis, so say get a certain working point, a certain working range where the Opamp switches on and off. Now we can say expect, because there is no resistor here, that the hysteresis resistor is endless. And I have to say, and had not expected that it switches quite precise. Let's do it again. So, and now I turn again the potentiometer to pin 3. But now I turn not the potentiometer to pin 3, but to pin 2 here. That's the upper here. Let's see what happens. There's a certain range here. That range is more wide. I can feel it on the setting of the potentiometer. But anyway, it also means that you can use that property of a changing resistor value, thus a changing voltage on the pin 2. And now I turn that under potentiometer again. So you have to study for yourself how you can use this in practice. Thanks for watching. My camera runs out. Anyway, key is this part of the circuit. With this part of the circuit you can drive a relay out of a Opamp. That's the key, etc. Thanks for watching.